Okay, so this is equal to 0. Again, there's a cool derivation of this formula that I should skip over, but if you have the opportunity, you should see how it's done. Okay, so this is your formula, and we have 3 points, so we can use any of those 3 points to be our point, but we don't have a normal vector. But it turns out that we can find a normal vector by taking a look at a couple of vectors that are on the plane. And do you remember how to find a vector perpendicular to 2 other vectors? Remember?
No,
okay.
I don't think so.
Normal, take 2 vectors on the plane and cross them. So if you take 2 vectors that are on the plane, the cross product, if you remember, gives you a vector that's perpendicular to both of those 2 vectors. Now, which way you cross them doesn't matter, because whether it's going up or going down, it'll still work the same way. So we need the 2 vectors, first of all, and then we need to cross them. So those points themselves are not the vectors we're looking for. But if you take, one of them, and you take the 2 points that are connected to them, and then you could do head minus tail, or it doesn't really matter, but if we just practice doing the head minus tail, it's going to be this point, 1, 0, 4 minus 0, 0, 1 would be the first vector. So the vector 1, 0, 4 minus 0, 0, 1 is going to be the first vector that we're going to consider, 1, 0, 4 minus 1 is 3. And then the other one is going to be the point 0, 1, 3 minus 0, 0, 1. And again, that's going to be 0, 1, 3 minus 1 is 2. So we have these 2 vectors. We take those 2 vectors and we cross them. So 1, 0, 3 cross 0, 1, 2. And so the cross product, ooh. All right, JK. So this is the point in the problem where I would just punch this into a computer and get the answer. 103, 0, 1, 2. But I want the result so we can graph it. So let's do a cross product. So in the I direction, it'll be 0 minus 3. So that's negative 3. In the J direction, it's going to be negative 2. And in the K direction, it'll just be 1. I hope that's right. And if I look at the picture, I kind of see this plane going up when the X and Y are both positive. So the normal vector must be going the other way. If it's going upward, then it's going backward. We'll take a look at all this stuff, because I think this is really cool to be able to visualize all these little pieces that we're getting. Okay. So now that we have a point, we'll choose, just for simplicity's sake, let's choose the 0, 0, 1 to be our point. Again, you can choose whatever you want. But 0, 0, 1 has more zeros. And then normal, we'll call it little n or capital N. So it's a vector we just found, minus 3, minus 2, 1. So let's just plug it into this formula. That's a minus 3x minus 0 plus negative 2 y minus 0 plus 1 z minus 1 equals 0. Okay. So this is minus 3x minus 2y plus z minus 1 is equal to 0. And we could leave it like that. This is a valid equation of a plane, but just for the sake of being able to graph it, I want to solve for z. No big deal. Also, I guess if you're going to find the integral, you probably want to solve for z because you want this to is equal f of x, y. So I think if you bring everything over to the other side, everything will be positive. 1 plus 3x plus 2y. All right. So that's our plane. And then you just take that plane, you put it in to the equation, you integrate it, and then your limits are going to be 0, 1, 0, 1. So I think the integral part here would be a piece.
Yeah, that's pretty easy.
Okay, so I am more excited about graphing it. So let's take a look at this graphically. I'm going to clear these plots. I don't like this box, so I usually take away the box. And let's start. Actually, before we start with the plane, let's start with those points that they gave us. Make it all dramatic and exciting. So we have 1 point. Another point. There's a 0. It's 104. Can't see it, so we need to zoom out just a tad. Oops, that's in. There it goes. And then another point. So we got those points. Let's do vectors. We found a vector. What was that vector? The first vector?
1, 0, 3.
1, 0, 3. So 1, 0, 3 is not really that meaningful for us if we just see it in standard position. And so I'm going to change the initial point to 0, 0, 1. And so now this makes a little bit more sense for us because now it looks like it's actually connecting those 2 points. Whoops. What was the other vector?
0, 1, 2.
Again, let's take that from not in standard position. All right, so this is what we got, and then let's finally get our normal vector. And what was it again? It was minus 3.
Minus 3, minus 2, and then 1.
So that normal vector, again, if we put it in one of those points, let's put it on 0, 0, 1. So it looks like it's perpendicular to those 2 other vectors, if we look at it from a certain point of view. All right, let's finally draw the plane. And the plane was, I think, 1 plus 3x plus 2y. Is that right?
Yes.
Yeah. So it looks like those vectors, those points are on the plane, the vectors are on the plane. It looks like that normal is actually perpendicular to the plane. There's some cool settings here where you can adjust the transparency and you can hide the edges, hide my edges. So you can kind of see a more smooth surface. And then what's really cool about this is that this actually was made for studying multivariable calculus because it addresses things like the integral as well. So what we're going to do is we're going to take this and what are we going to do? We're going to take a look at a region. So in our two-dimensional region, it's going to go from 0 to 1, and the x values are going to go from 0 to 1. So those were our limits. And then let's just simplify this with smaller grid lines. And then this is the plane that we're looking for. I'm going, I'm realizing I'm going fast here, but I will copy the link to this if you decide that you're interested in seeing this graph. Okay, so the rectangular region has a bottom, looking at it from a two-dimensional point of view, it goes from 0 to 1, and then it goes from 0 to 1. Okay, so for some reason it's not drawing it for us. Why? Maybe if you show the Riemann partitions. So this is exactly the volume that you're looking for. And my computer is going super slow now because this thing has a lot of information. So if you're interested in viewing this a little bit more, ooh, come on. I found that I can copy this. I hope it doesn't crash. And I will paste it in our chat, and then you can decide if you want to to paste it into your, is that even possible? If you're interested, it's there.
Okay.
But that allows you to view this thing. I think I might need to cut this out. And it's kind of cool because it's all these things that we found by hand, and now you get to kind of see it, and then you get to view it. And then if you make the partitions, you know, smaller, of course you're going to get a more precise, just like in Calc 2, you're going to get a more precise approximation to your integral. And then when you compute it by hand, you can compare your integrals and stuff. All right.
Okay.
So we got a crash course on finding equations of planes, and you're doing really, really well with like pumping out all this double integral stuff. So good, awesome. All right. Any other issues? Do you want to talk about anything else in particular?
I don't think so.
Where are you at now? What are you looking at?
I started looking at just going through like previewing chapter 6. And vector fields are pretty familiar.
Oh, awesome. Okay, good. So it looks like you're in pretty good shape here. Trying to stop recording.